Welcome to ARC204, Anatomy of an AWS Region. How many of you have wondered how AWS builds new regions and perhaps what you could learn from that to apply to your own architecture? Well, that's what we'll cover in this talk this morning, and we'll get kicked off with our agenda.
So in today's session, we're going to start by talking about the AWS global infrastructure. We'll talk about regions, availability zones, and the global network. We'll then talk about how we at AWS build for resiliency and how you can apply those concepts when building your own workloads on AWS. We'll take a really fun journey back in time, showing you how we used to build regions back in the day. We'll talk about how the landscape changed and how that didn't scale for us anymore, and then jump into how we build regions today, including how we handle dependencies, the people involved, the mechanisms we've built, and the tooling we have to support the region build process. We'll wrap it up with some key takeaways, and then hopefully you'll have some time at the end. If you have any questions, we'll stop by right outside the door. But first, let's do some quick introductions.
I'm Don. I'm an engineer in EC2.
And my name is Michelle. I'm a TPM, also with EC2. So let's kick us off with an overview of the AWS global infrastructure. On the map here, you'll see all of our AWS regions. The regions in green are the regions that we've already launched, and the regions in red are the ones that we're working on as we speak. The AWS cloud spans 108 availability zones within 34 geographic regions. We have announced plans for an additional 18 availability zones and 6 new regions. The 6 new regions we're working on include Mexico, New Zealand, the Kingdom of Saudi Arabia, Thailand, Taiwan, and the new EU sovereign cloud. We also have other infrastructure offerings, such as points of presence and local zones, but we won't be covering those in today's presentation. Next up, Don will expand on how to think about our global infrastructure.
So the highest level of abstraction in AWS's global infrastructure is a partition. And a partition contains one or more regions, and each AWS region belongs to a single partition. Most folks are probably familiar with the AWS or the commercial partition, since that's where the vast majority of our regions are. But we also have a partition for the US GovCloud, China, and the upcoming EU sovereign cloud. Partitions also include an instance of our global services, so IAM, CloudFront, Route 53 are global in nature, and each one of those are contained within the partition. Beyond the partition, there's regions, and Michelle will dig into what's in a region.
So regions at a high level are just physical locations we have around the world. And each region has multiple availability zones, and those availability zones have multiple distinct data centers. And AWS has always prioritized resiliency. So these availability zones are meaningfully distant apart, about 60 miles or 100 kilometers. And the reason we do this is to prevent correlated failures. So they're on separate floodplains, different electrical grids. They don't share power or cooling. And so if there were to be a natural disaster that impacts an availability zone, it's unlikely to impact the other availability zones within that region. However, we do need these availability zones to be close enough to minimize latency within the region. And on the software side, when our engineering teams deploy changes to their services, so say they make a change to, say, EC2, when they deploy changes to their services, they deploy one availability zone at a time. So if they deploy a change, it'll go to the first availability zone, there'll be a waiting period, and if everything looks good, the deployment will move on to the next availability zone, and so forth. And this is also done to prevent correlated failures. Next up, Don's going to expand on how we connect these AZs and regions to the AWS global network.
So within a region, you have multiple availability zones, and they're interconnected to each other with multiple distinct high bandwidth fiber connections. Within a region, we also have these locations called transit centers. Transit centers serve a couple of purposes. The first is that they interconnect the AZs to each other. Second, they provide connectivity to and from the AWS Global Backbone Network. That network allows traffic that leaves region A and is destined for region B to stay on AWS's privately maintained backbone network. So you don't have to worry about traversing the public internet to transit traffic between regions. Finally, transit centers are highly peered with the internet backbone, so traffic that needs to egress to and from the internet will do so through the transit center sites. This is all well and good, but what does this actually mean for you as a customer?
So we've talked about how AWS designs our global infrastructure with resiliency in mind, but at AWS we operate under a shared responsibility model. So when we talk with our customers, we always recommend that you keep this in mind as well. So understand the scope of the services that you're using. For example, are the services you're using zonal or are they regional? As an example, we have an architecture diagram here. A zonal service would be EC2. When you launch an EC2 instance, you specify the availability zone in which you launch it. An example of a regional service would be simple storage service or S3. When you create an S3 bucket, you specify the region in which you want to create that. And the reason why this is so important is because you can use this information to plan your operational response. It's important to understand which metrics are important to your business and at which thresholds you want to alarm. That way you can make business decisions such as, in the event of a disaster recovery scenario, at what point would you want to fail over? Don's going to talk you through a specific example, but at a high level, it's also important to test this out. For example, by having game days. So not only is it important to plan this out, but make sure that it actually works. And we actually do this in region builds as well. Right before we launch a region, we have game days where we simulate failures to make sure that services recover quickly and as we expect them to do. So that's another thing we always recommend our customers do as well.
Yeah, so in this example, very simple application where you've got a few web servers behind a load balancer. Those web servers are in an auto-scaling group spread across a few availability zones, and then perhaps those web servers are storing and retrieving some files from S3 and grabbing some data from some tables in DynamoDB. So looking at this architecture, well, what could be some of the failure modes? Well, you know, EC2 is a really great service, but sometimes either when you deploy software onto a host or hosts can get impaired, you can start to experience failure on an instance or even in an availability zone. Most of the time, your Elastic Load Balancer will recognize that through health checks, take those instances out of service from the load balancer. Auto-scaling will detect, hey, these other hosts are running a little bit hot, let me launch some more hosts, and problem solved. You can run into scenarios where you get a gray failure. And what a gray failure is like maybe 50% of the traffic that's going to that instance is getting through and 50% is failing. Or maybe my EBS volume is impaired and degraded but not fully offline. In some of those scenarios, your load balancer may still be passing health checks on that instance, but your overall application may not be healthy. This is where your business metrics come in. If you've got a metric and an alarm on order rate and order errors, you can use those to decide, hey, my business is impacted enough that we need to take some manual action here. So for example, in that case, you could scale up some additional instances in your auto-scaling group and manually bind those to the load balancer or manually remove instances that are unhealthy from the load balancer. And that's something that you'd want to have a business decision for, get the right leaders on a call, have a run book for your operators to actually go through and do that, and have practiced it in a game day, as we mentioned, rather than on the spot. So understanding both the zonal and regional nature of the services that you're working with and having those run books and game days prepared ahead of time will allow you to effectively respond during an incident. Now we can start talking about how we actually build regions, which may be why you came to this talk.
Okay, so now that we're all on the same page with the AWS global infrastructure, let's talk about how we build those new regions. Now, Don and I, we assumed that you did not come to this session to actually learn how to build your own region and figure out how to operate it. But hopefully you can learn a bit about what we've learned while building regions over the last many, many years. And honestly, region builds have changed a ton over the last several decades.
Yeah.
But one thing that's remained fairly consistent is that we have two primary work streams. And the first is the physical. I know we like to talk about the AWS cloud, but at the end of the day, it's still just physical servers. So the physical work stream involves everything from procuring land, considering expansion options, looking into fiber and power constraints, building the physical data centers, ordering, landing, and cabling all the racks, and connecting it all up into the AWS network. The second primary work stream is the software build. And we're going to dive a lot deeper into the software side of things. But at a high level, we have to go all the way from being able to launch a host that we can deploy software to, all the way to building out all of the AWS services that our customers expect when they're using a new region. So things have changed a lot, Things have changed a lot, but we want to take you back on a journey to 2010 because it's really cool to see how we used to do things and how things have changed. So with that, let's take it back to 2010 when we started building the first region in South America.
Yeah, so in 2010, AWS announced the launch of the Sao Paulo region in Brazil. And it was AWS's 8th region. The first reInvent hadn't even happened yet. And as you can see from this kind of legacy-looking blog post, AWS and EC2 looked a lot different at the time. We announced the launch of this region and talked about, all 15 of our services would be available there. So, it was a pretty different time. Well, looking at this, well, how did we build regions back then? And in order to do that, we're going to have to introduce you to someone, and that's John. John is a bootstrap ninja, which was actually his job title. And what John would do when we needed to go build a new region is we'd wait for those, the concrete to get poured and the fiber to get pulled and the power to get powered. And then John would pick up 3 jump drives and then jump on a plane to fly to the site that we built the new data centers out. The 3 jump drives were for each availability zone. And they would contain the initial certificates and configuration that were needed to build that AZ. And he'd walk into the data center and plug in the jump drive to the first host that kind of caught his fancy, and then start manually installing our base software and our provisioning stack. And that would take a fair amount of time. And obviously you got to drive between each availability zone. And John was a great guy, but he only wanted to work maybe 10, 12 hours a day. So this wasn't really a scalable process, right? AWS is oh, we're very scalable. This was not a scalable process. And for one, we actually have on our team 2 people who used to do this job. And you need to know a lot about a lot of things to be able to walk up to hundreds of racks of blank servers and go, all right, I'm going to start to set up DNS now. So, one, John needed to be a pretty highly knowledgeable person in the bowels of how AWS infrastructure worked. No human is perfect, so, especially with configuration, it's really easy to fat finger something. And then when you fat finger something, you'll discover it later and then need to go back and figure out where you did it. And this is flying people around the world is just not really, a sustainable model if you want to be able to build a couple of regions at the same time or, launch many regions. Looking back, so we moved away from the bootstrap ninja process pretty early on, actually shortly after Sao Paulo. But even if we tried to continue on that model, it would have become unsustainable for other reasons as AWS continued to innovate, and I'll talk a little bit about that. AWS, we are continually innovating on behalf of our customers. One of the things that's evolved over time is in the early days, we built services and those services ran. We started to build services on top of AWS. And most of the AWS services that we build today run on top of EC2. It's kind of a joke, like the Scooby-Doo thing where you pull the hood off somebody. If you look, it's EC2 most of the time under the hood. Like, we're running the compute for the vast majority of our services. Interestingly, we actually can run EC2 on EC2, which, is kind of, wrap your head around that a little. The other development that we made that was a pretty big change in this space is we started to build new regions as IAM opt-in regions, which is a great thing for customers, because when we launch a new region, your account and your IAM information doesn't exist in that new region until you choose to opt into it, which is great. That's a great feature for customers. It would have been really hard if we were still, running people around and trying to, install this, because now we need to build the identity stack there. In addition, the customer landscape has changed. Michelle mentioned the EU sovereign cloud, and that's driven primarily by digital sovereignty and data sovereignty requirements that have evolved over time. Customers have wanted to run more sensitive workloads on AWS, and as a result of that, there's more stringent restrictions and guidelines that we need to follow, which have the need to both build more regions and build them to different security standards as that's improved over time. And finally, there's the value proposition of cloud itself, which is the ability to have global reach. I can be, sitting in my house, which is kind of just west of US East 1, and I can launch an application in Cape Town, South Africa, or Kuala Lumpur, or, if I'm a small business, I've got the ability to launch my application globally. And in order to be able to do that, we want to have more global locations for customers. So with all that said, and the fact that the Bootstrap Ninja thing was never really going to pan out for the long run, what does this look like for us today?
Well, so in response to all of these changes that Don mentioned, AWS just continued to innovate and deliver more AWS regions for our customers. And so these are some of the launch announcements from the recent regions that we've built. So definitely a lot more regions, but this would not have been possible using our old approach. And so what did we do? Well, we build AWS using AWS. So instead of having this very sequential process where we had to build the data centers and then start the software build with the Bootstrap Ninjas, instead of doing that, we parallelized the work streams. So we've started a new region build. We're starting to procure the land. We're building the data centers. And what can we use? Well, we have all of these existing AWS regions all around the world, so we'll just use that to bootstrap the new region. So now, instead of waiting for the physical workstream to complete, we can work on the physical and get started on the software build in parallel. So we have our Bootstrap region, which is an existing AWS region, and we're extremely careful when deciding which region is going to act as the Bootstrap region, because that region is serving external AWS customer traffic. And so we consider things such as capacity constraints, so making sure that there is sufficient capacity for us to use during the region build without impacting external customers. We look at the latency between the Bootstrap region and the new region that we're building, and we look at things like fiber and bandwidth limitations that there might be. So at this stage in the build, we started constructing our data centers, and in the Bootstrap region, we have created a VPC. And even this early on in the software build, we're already designing with resiliency in mind. We've created our 3 availability zones, and all of the services that we bring up in this Bootstrap VPC, they believe that they exist in the new region that we're building. Great. So we have a VPC. What's next? Well, we start bringing up services. So Don's going to kick us off with the first thing we need to do in that VPC.
Great. So we've got an empty VPC. We did it, right? No, not quite. Well, what do we need to do? So the first thing is, well, we need a host, right? Because we want to build some software, probably going to need a host to do that. So let's launch a host and see what happens. Okay, well, wait, I need to deploy software onto that. How am I going to do that? Well, I need to be able to talk to Amazon's deployment system, and I'm going to need the deployment agent on that host, And I probably need to be able to tell the deployment system that, like, I'm trustworthy Amazon guy and not scary hacker guy. So I'm going to need things like DNS and PKI and RPMs. But I just got an empty VPC. Like, how am I going to make this work? Well, so there's a lot of creative engineering that actually goes on throughout this process to kind of break these, because there are services that we have in AWS internally that do DNS and do PKI and do RPM repos, but they need hosts to build, but I need those things to make the host work. So like, how do I do this? Well, DNS is really just like, a database that's like names to numbers, numbers to names, and PKI is just kind of like web server, and so is RPM. So like, maybe I can just kind of like, I don't know, hack something together. So we'll launch another instance in this VPC, and we'll put a couple of web servers on there, maybe a DNS server, use like a little Dynamo or S3 in the Bootstrap region, and oh great, now I've created DNS PKI RPM repo, and I can talk to the Amazon deployment system and deploy software onto my host. So now we can build all of those early services that I just broke the circular dependency for. And yes, because that instance is thrown together with various parts that we kind of hacked up, it is actually called the Franken instance. So now that we've been able to build kind of the things that turn the lights on within AWS, like DNS and PKI and RPM repos, can we start building some AWS services? That would be fun. Can we do that?
Not yet. So we have all these hosts that we can deploy software to, but what does every single service need to do? Well, it needs to be able to authenticate. So some of the first services we bring up are the authentication services. So think of services like Identity and Access Management, IAM, and Security Token Service, STS. So these are some of the first services that come up in our VPC environment. And earlier on, Don mentioned opt-in regions. Well, as of early 2019, when we build new regions, they're opt-in regions. And so services won't actually work unless they're opted into the region. So it becomes even more important that the authentication stack is up really, really early. So these are some examples of all of the opt-in regions that we've launched recently since that announcement. Great. So we have our VPC, we have hosts we can deploy software to, and now our services can authenticate. Unfortunately, there's still a whole other list of dependencies that the majority of services have. So Don's going to talk about how we handle those next.
Cool. So we want to build EC2 because EC2 is the coolest, we think. So in order to build EC2, I've got IAM, great. So now if people call, EC2 run instance, I can at least authenticate that call and know what account they are and all that kind of fun stuff. Remember when I mentioned earlier that everything largely builds on top of EC2 and AWS uses AWS to build? Well, EC2 actually uses some of AWS to build. EC2 stores some data in S3 for object storage, and we use DynamoDB for key value storage, which is great. I mean, they're great services. But wait, so S3 and DynamoDB run on EC2, but EC2 uses S3 and DynamoDB to store stuff. How are we going to make this one work? This one seems even harder than the one I talked about before. Well, in production, this works fine. Those are regional services, and we do things underneath the hood to have zonal affinity for our S3 objects and our DynamoDB tables so that we're able to maintain resiliency for customers. But this initial bootstrapping thing is kind of a problem, right? Because you need all that stuff there to be able to do the regional resiliency. This one's a little bit tricky. And we said we wanted to have services believe they were running in the region that we're building, even though that really doesn't exist yet. Well, hold on. Let's take a step back. We've got Dynamo in the Bootstrap region, and we've got S3 in the Bootstrap region, and they have a different DNS endpoint and stuff like that, and they won't use the opt-in region auth, but, well, wait a minute, maybe I can just kind of stick something in there and call it a proxy, and have that proxy authenticate against the in-region auth and listen on the s3.buildregion.amazonaws.com, and then just temporarily store stuff in S3 and DynamoDB in the Bootstrap region until those services come up, and then we'll just kind of move everything over there. What have I just created? I've created a mullet because it's build region in the front and Bootstrap region in the back. Business in the front, party in the back. So now, great. So we've broken the circular dependencies for EC2. Now we've got everything that we need to actually build EC2. How do we do that?
So once all of the dependencies are in place, we bring up EC2 and some of the other core infrastructure services we need, like networking services. And at this point, on the physical side of things, the data centers have been constructed, we've landed and cabled the racks, and everything is connected to the AWS network. So what this means is we can actually start launching hosts in the new build region. And that means we can start building out all of the AWS services that we'll need in the region. I've just included a few examples here, but obviously we will need to bring up every single service that needs to be available before the region launches. Now, I mentioned we just bring up EC2, but that's a very simplified way of looking at things because EC2 is not just one service. EC2 is actually hundreds of services. And so it's a bit more involved than we make it seem. So to put this into perspective, Don's going to walk you through one of EC2's most foundational API, run instances, and talk you through just how many services are involved, even just within EC2.
Yeah, so customers generally think of a service, and they think of EC2 or S3 and Dynamo, and that makes sense. But a service has a bit of a different meaning inside of Amazon. So here's a run instances call, pretty typical. Kind of our bread and butter in EC2 is customer wants an instance, and we give it to them. And we'll put up, what does this run instance call actually look like under the hood? Oh my. So don't try to read that. It's up there just to kind of make you, do the cringy, guy. So this is actually a screenshot from our internal API orchestration software. And I'm hovering over the little box at the top, which is where our run instance call starts. And then all those little green lines are what that one box will call at that step in the process. Each one of those boxes on the screen represents what we would consider a service. Amazon follows this thing called the 2-pizza team model, which is a team should be the size that you can feed with 2 pizzas. So each one of these boxes on the screen is a service, which for us is operated by a 2-pizza team. So if you start to do the math on this kind of mentally and go, well, wait a minute, that's what it takes to run an instance. Like, what about security groups and VPCs and EBS volumes and all this other fun stuff? You start to add it up and go like, holy cow, that's a lot of teams. So how do we actually corral all these teams and be able to do a build like this at the scale of Amazon? We'll talk through how we kind of decompose this.
So Don's example demonstrated that there are a ton of dependencies involved, even just within one EC2 API call. And so dependencies are quite challenging because they're difficult to keep track of, and they change all the time. For example, when a service announces a new feature, they might introduce new dependencies. Or if there are company-wide efforts to, say, deprecate a service, that could have region build dependency implications as well. To put this into perspective, during a region build, we have over 100,000 different dependencies between services, and so ordering and scheduling all those dependencies becomes quite tricky. So one thing we do is we kind of bucket them into waves. So I've put a very simplified example here, but essentially we would bring up one wave. Once they're all up, we'll move on to the next wave. And the wave actually gets broader as we progress through the build, once the core dependencies are available. And the way this works is within the wave, each dependency is continuously checking on the health of its dependencies. And once its dependencies are healthy, the service can come up. Not only is this really important during region builds, but it's also critical during operational events, which Don's going to talk about next.
So during an operational event, EC2 services specifically, but broadly a number of services at AWS, follow this practice or this tenet called static stability. And that's basically if my service goes offline for whatever reason, it should try to bring itself back up without manual intervention. And we want that for EC2. You know, I mentioned that like lots of stuff kind of runs on EC2, both internally and for all you customers. Like it's really, really critical to the business. And things like power events can happen in data centers. And you know, a power loss event inside a data center, you know, it's basically a very big, like, have you tried turning it on and turning it off again? Which, if it's your home router, it's kind of implied, like, yeah, if I unplug this thing and plug it back in, it probably should work. If you unplug, like, an EC2 data center and plug it back in, it takes a little bit of work to actually make sure it's going to come back to life. We can use that same principle in region build to make these dependency waves work. And here's kind of what I mean by that. So when a service attempts to either cold start or restart, it'll only block activating that service. And what I mean by activating is like, I'm supposed to listen on port 80, right? So like, you know, only the things that are absolutely critical to get that service to listen on port 80 are the things that will prevent it from getting up and running. Once the service is running, you know, you can make calls to it and it'll happily return 500 errors because it's like, hey, I can't talk to anybody, you know, to any of my dependencies. But it'll at least be running, right? So it's kind of this two-stage is, am I running, am I healthy? And we can take advantage of that by launching a whole bunch of services at once, waiting and checking to see, hey, for these 50 services that I launched, are they running? And then we'll send some API traffic through the system and go, are they healthy? And once everybody's running and everybody's healthy, we can just move on to the next batch. So the dependencies basically sort themselves out in that little group. So we need like some high-level sequencing, but we don't need a bunch of low-level, like, first I do this and then I do this for 100,000 different things, because that would be quite tedious and basically a losing proposition because they're all changing all the time. So now, Michelle will talk through some of like the programmatics and tooling and things that we use internally to actually make this thing come together.
Okay, so we talked about the physical and the software aspects of a region build, but we haven't really talked about everything else that is involved. So next up, I want to talk about the AWS builders, the mechanisms we have in place, and the region build specific tooling. And we'll start with the people. So AWS is a very large and global company, and during a region build, we bring up over 1,500 internal and external services, and these teams sit across the globe. Even within just EC2, we have major hubs in Seattle, DC, Dublin, and Cape Town. So we're constantly working across time zones. And these teams, they're maintaining their services in all of the regions. They're developing cool new features like the ones you've heard about at reInvent this week. And on top of that, we're asking them to build out their services in all of these new regions and availability zones. And this requires a ton of collaboration, not just within EC2, but across AWS, across the globe. So we've implemented certain mechanisms within AWS, which aren't even region build specific, to help facilitate this process.
Yeah, so I'll talk a little bit about some of the mechanisms we use, because this is perhaps some of the things that you can start to think about how to adapt and bring into your own business. A mechanism, which is kind of an Amazonian term, is you could pretty much think of it as a repeatable process that everyone will kind of automatically follow. And there's kind of ways that we steer people to just kind of do these things. The first is everything at Amazon is a ticket. If my service is impaired, that's a ticket. If I'm on team A and I need team B to do something, that's a ticket. If I need to change my benefits, that's a ticket. If the toilet's broken in my building, that's a ticket. Everything is a ticket. And you know, internally, you know, people will be like, tickets. Tickets are actually a really, really good thing. Why is that? Well, one, when I was new to Amazon and someone was like, hey, everything's a ticket, and I'm like, oh, okay, cool, great. Well, once I learn the process to figure out, hey, I've got problem X, all I need to do is figure out what is the right team to cut a ticket to. Once I figure out how to do that process, I can pretty much self-service solve any problem that I come across, because all I need to do is figure out where do I get the ticket to, and then someone will like take it from there and be like, oh, you cut this to the wrong team, I'll move it over here. Or, oh, hey, sorry about the toilet thing, like let me go get on that. So in addition to kind of making it easy for anybody to self-service, addressing and solving problems, tickets are searchable, tickets are auditable, and tickets are discoverable. So, you know, if I have a problem and I like search and see, oh, somebody already cut a ticket for this, I can just follow it. We audit tickets. So like as we go through the build process, we'll keep track of tickets. And if we see like, man, we keep having the same problem, like build over build, we'll go and talk to that team and say like, hey, like we keep running this issue where like, we gotta, ask you to do this manual thing, and manual things are really sad. Can we, not have manual things? We've actually been doing some work with analytics to look at, not just the tickets that EC2 is involved, but actually like what is every ticket that got cut for this region build, and what phase of the build did it happen in, and what was kind of like the subject matter of the ticket. And we've been playing around with like some generative AI tooling to be able to read this stuff and like summarize it to us so we can figure out like what are the common problems build over build. So tickets are great. Tickets are great. The next mechanism that I'd like to talk about is this thing called an ORR. An ORR is an operational readiness review. And we've got a little web-based tool. It's kind of like a checklist that you fill out. And an ORR digs into, the engineers on the team will sit down and kind of fill out like, hey, okay, I own this service. Here's what it does. Here's what its fault container is. Here's what its failure mode is. Here's the pipeline. Here's how we've got the pipeline structured. Here's our key operational metrics. Here's our key business metrics. Here's how we're measuring those. Here's what our alarms are. And actually, as a principal engineer in EC2, I spend a fair amount of my time sitting with individual teams looking through their ORR before they launch a new feature or service to kind of look at like, are we measuring the right things? Do we have the right alarms on stuff? Are we missing some key functionality and failure modes in this system? So ORRs happen right, before service launches to customers, and then periodically. Teams do them usually annually, sometimes more frequently, to look at, hey, this is what we wrote last year. What have we seen operationally that's changed, and what adjustments should we make to our alarms and monitors moving forward? Or, hey, we're going to build this new feature within our service, like let's repeat the ORR. The last mechanism I'd like to talk about is a thing you might have heard of it called a COE, which is correction of error. Anytime that there's any type of impacting event, the team that kind of owns the service, or even teams that don't own the main service that was impacted but were impacted as a secondary result, will write this document called a COE. And a COE talks about, what happened, what was the timeline, what was the impact, what was the root cause, and what are the action items that we're going to take, and what are the lessons learned. The most important thing about a COE is that it is not punitive. COEs are a learning mechanism. And what do I mean by that? Well, let's say you have a batch processing service written in Java, and it's pretty memory intensive, and you had a big spike in load, and that caused some impairment. And when you dug deep into the root cause, you figured out that hey, if we use this type of garbage collector, it has a certain behavior, and when we switch to this garbage collector, it doesn't have that behavior, and we would have avoided impairment if we made that change. Well, that's a lesson learned to anybody else who's running a batch processing application that's memory intensive, to look at what Java garbage collector you're using and maybe think about doing a little bit of testing to switch to the other one. So these are the types of things that will come up in COE reviews internally that you kind of share and go, hey, we should have had this metric or alarm earlier on. If you run a similar workload, consider having this alarm or metric. The other piece that I mentioned is root cause. Root cause is never operator error. It's really easy to say that, but at Amazon, and I'm sure at all your companies, we hire really good people. And if Don was on an ops box and was making some changes to a database, and I thought I was in the test environment, but it turns out I was in production, which I'm sure has never happened to anybody in this room. And I ended up making a change to a production database. Well, is that Don's fault? We hired Don. Don's a good guy, I think. We hired him. He's a smart person. He's a good person. Works really hard. So is it really Don's fault that he didn't know that he was on the production box and not the test environment box? Well, no, that actually sounds like a problem with the fact that it wasn't blatantly obvious to Don that you are on a production box, be careful what you're doing. So that's the root cause. The root cause is bad tooling. The root cause is an operator error. And that helps to kind of foster that culture of this isn't a punitive thing. I've sat in many COE reviews where we talk about what the operator did. Everyone in the room knows who the operator was, but it doesn't really matter because the operator really could have been any of us. So these mechanisms are really great to establish, in a way that will work for your business over time, to be able to kind of reinforce some of these techniques and be able to continuously improve and audit your process. Michelle will dig into some of the specific tooling that we have for builds themselves.
Cool. Yeah, so we have some tooling that helps facilitate the region build. And so I mentioned that even within EC2, we have so many different dependencies. So one tool that we rely on very heavily is a project management tool. And it captures some of the high-level dependencies between all of the services and build duration, so how long it takes to bring up a particular service, and the overall end-to-end schedule. And the reason why this is so important is because when we announce that we're building a new AWS region, we typically provide an estimated launch date, we plan on launching this early 2026. And we want to meet the commitments that we make to our customers. So it's really important that we know that we're on track to delivering the region by the customer commitment date. And so this high-level schedule, we look at it every single day. And if there are any new risks or delays, we can escalate that quickly and see if we can mitigate those risks or delays so that we can still deliver the region on time. We also have extensive internal documentation specific to region builds. So any service team that has engineers that want to improve their region build automation, as an example, they can reference this documentation and look at what tools are available to them, depending on what type of region build they have. And then lastly, sometimes there are gaps in our tooling. Because region builds have changed so much over the last few years, things change all the time. And so when we notice that, we've seen 10 different teams encounter the same issue during a region build, that's not a good use of anyone's time. So we take those problems and we bring them into programs so we can centrally solve those issues, either by developing new tooling or doing some Band-Aid fix for the current region with a long-term fix for future regions. That way, instead of having all of these engineers get frustrated by having to fix this problem, instead they can just focus on maintaining the health of their services and developing cool new features, and hopefully keep our engineers happy. So as we mentioned earlier, we really don't assume that you're going to be building your own regions and trying to operate them yourselves. But we do have some key takeaways we want to share with you that could hopefully help you within your own business.
Cool. So First, design for resiliency in your systems. One of the things that I hope at least you came out of this talk with is that like the AZ model and the region model is not something that gets slapped onto AWS software right before we launch, but it's deeply ingrained in how our software functions. So much so that we need to recreate independently mapped AZs like from the get-go in building a new region. And one of the reasons that we need to have this really elaborate region build process is because we have that strong isolation barrier between regions. We don't want an incident in region A to affect region B, and we hold that line very, very, very strongly. So you can use those same principles when designing your software. One of the most common ways that customers will use AWS provided, call them fault containers, in their own software is use different accounts for different components of your software. And if you're deploying, hey, I've got Don's awesome widget service, and I'm going to deploy that in US West 2 and US East 1, have one account for Don's awesome widget service for US West 2, and Don's awesome widget service for US East 1. So if I'm trying to go and mess around in US West 2, I don't accidentally, if we're in the same account, I can accidentally, which again, never happens to anybody, be messing around with the wrong region. And using the account fault containers really is a strong way to prevent that type of spillover. Second is, when should you centralize a problem versus when you should distribute a problem? And what do I mean by this? When we switched from the Bootstrap Ninja to the software build using the Bootstrap region, initially the way that we built EC2 was that we'd have that schedule, and each one of those teams, remember the very scary chart of boxes, each one of those teams would get a ticket from a TPM that would say, hey, it's time to build your service in region XYZ, like, get to work. And corralling that amount of work is really, 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 really hard to do. Like, that is a really hard TPM job. It's also really hard for the service teams because the region build is kind of like a different weird space, and there's a lot of like unique knowledge that you need. So that was like the distributed model, and that's actually what Amazon usually defaults to with our 2-pizza team, is that 2-pizza team owns everything for that service, soup to nuts. In recent years, we started to look at that and go, well, wait a minute. If every one of my 1,000 teams spends 8 hours a month on region build, I am making up numbers. Well, wait a minute. That means I'm spending 8,000 hours across 1,000 teams on region build. And if you have a job that takes you 8 hours a month, you're probably not incentivized to optimize that process, right? Because there's not that much work when you've got a whole bunch of other things that you could optimize. But what if I took that 8 hours away from every one of those teams and gave it to a central team and said, hey, now you're in charge of building EC2 in a new region. And you're going to take those 8 hours of work off of those 1,000 teams, and I'm going to resource you semi-appropriately to take on this task. Well, now they have 8,000 hours worth of work. So that team is highly incentivized to optimize that process and own that process and figure out how they can make it better, because no one wants to do 8,000 hours of work. I'm a software engineer. We are notoriously lazy, right? Like, if you give me something that I have to do 3 or more times, I'm going to write some type of thing so I don't have to keep doing that. And like those same incentives like apply within an enterprise. The key to doing this successfully is, one, knowing like when you want to make that decision, right? Like when it makes sense to just have 1,000 people do something versus have one person do something 1,000 times. We have the shared responsibility model that everybody knows and loves. Having that same shared responsibility model for a centralized team is really important. Defining that early on is really important. What is the customer, the service team responsible for, and what is the centralized team responsible for? the sooner you're able to establish that, and the sooner that actually works for everybody, and they're like, yeah, I'm okay being responsible for keeping my region build automation healthy. If you're gonna take care of my region build for me, like, I like that. You know, that's like undifferentiated heavy lifting that you're taking over for me. That's good. But defining that early on, establishing that through tooling, and then, you know, going down the centralized road can be really, really game changing for your business. And kind of to that point, and I started to allude to it, everything should be in code, and that code should be checked into source control. So obviously, software code gets checked into source control. Okay, cool. Configuration, that should be in code. Infrastructure definition, that should be in code. Documentation, that should be in code. Everything should be in code. Why? Well, one, you centralize where, you know, your knowledge and configuration is. Similar to the ticket thing, it's searchable and it's auditable, right? So one, from a, you know, code review perspective, that's really, really good to have. Two, I spend a lot of time searching on code.amazon to figure out, like, hey, why is this thing like this? And then I can read the code and go to the team and be like, oh, hey, like, the way that you're doing this configuration automation is like not gonna work, and like, let me show you how to do it. Or if we run into a problem where it's like, hey, we wanna improve the way that teams do their configuration, we can find every instance of that in code just by searching, and then like automatically create PRs for those teams to go like, hey, we made your life better. You know, just, can you please merge this code review? So capturing things in code is really important. Especially if you've got a system that you want to deploy to multiple regions, having some type of automation or scripting to automatically spit out, like, here's my configuration for US East 1, here's my configuration for SA East 1. Like, those types of things, you know, if you do it early on, you get to reap the benefits of that many times over in the future versus, you know, if US East 1, then, like, that's sad. So everything in code, and Michelle will dig through some others.
The fourth one is measure the problem and the solution. So at AWS, we're a data-driven company. And so if you think there's a problem, you better have the data to back that up, because that can help drive prioritization decisions. And once you've implemented a solution, you can then measure and make sure that it actually fixes the problem you set out to fix. So we highly encourage, we require that everyone comes with data when you think there's a problem, and we recommend you do the same. And then lastly, leadership engagement. So region builds have a ton of leadership visibility, and our leadership is actively involved in the region build process. And we have a very healthy escalation culture at AWS. And when I say escalation, that might have a negative connotation, but it's actually seen as a very positive thing, because with region builds, if there's a new risk or a delay or there's a misalignment between teams, it is critical that we can very quickly resolve those issues and determine a path forward efficiently. And so if we can't do that internally between teams, we escalate to our leadership to help make that decision and drive the right outcomes. Because if we don't do this, it's going to be very challenging for us to deliver regions on time. So hopefully some of the lessons that we've learned over the course of building all of these AWS regions can be helpful. We have a few additional resources here. There's a presentation tomorrow about scaling on AWS that might be interesting. And then we have 2 Amazon Builders Library resources that are very relevant to what we talked about today. The top QR code is for the first article, and the second QR code is for the second article. If you have any questions for Don and I, we will stick around for about 5 minutes or so feel free to come up with any questions you may have. We really, really appreciate your time. This is the first time we've actually ever talked about the AWS region build process in public, so we would really appreciate your feedback. So please, please, please take that survey, and thank you.